Okay, so when you look at this one, it says the perpendicular bisectors of the sides of a triangle are all congruent. So this is a real fancy definition. So let's think about what they're saying here. If I have a triangle, the triangle has 3 perpendicular bisectors. Right? So like if I take here from B and I draw a line down, from it I have a perpendicular bisector that goes between them. So actually that line is here. Right? It doesn't necessarily be an angle bisector because this triangle is not isosceles. Right? So we're talking about something different here. But if I have a perpendicular bisector here on this side, here on this side, and here on this side, they are all congruent. That's the wrong word, not congruent. They're all concurrent at a point equidistant from the vertices. So where all these perpendicular bisectors meet at this point is equidistant from C, from A, and from B. So that means all of these blue dashed lines are equal to each other. Okay, that's what this is telling me, the concurrency of perpendicular bisectors. So it says if you have this drawing, then D, F, and G all intersect. That means they all meet at point P, and then P to A is equal to P to B, which is equal to P to C. Okay, so the last one were perpendicular bisectors. They were cutting the sides into equal pieces. This is an angle bisector. So these lines are cutting the angles into equal pieces. So I'm cutting angle X into 2 equal pieces. I'm cutting angle Z into 2 equal pieces. And I'm cutting angle Y into 2 equal pieces. It says the angle bisectors of the angles of a triangle are concurrent. That means they all meet at a point, and this point is equidistant from the sides. So what we looked at before, perpendicular bisectors, when I cut the sides into equal pieces, then the point where they all met was equidistant from the angles. Now when I cut all the angles into equal pieces, then where they meet is going to be equidistant from the sides. So that means from Q to N, from Q to O, and Q to M are all equal lengths. Okay, so it's kind of doing the opposite of the perpendicular bisectors. Okay, so right here's the kind of problems we're going to have. It says if QP is equal to 3 times x plus 1. So from Q to P is 3 times x plus 1. And R to P is 5x minus 3. You want to know what's the radius of an inscribed circle of triangle JKL? So inscribed circle means if I were to draw a circle inside this triangle, it has to be on the inside. That circle would look like this. Okay, that's an inscribed circle. Now it should all be the same length. It should all be a circle. Obviously I did a bad job drawing it. Let me try it again. I don't know if I can do much better. Nope, not even better.
Can't you use some kind of tool on your iPad thing to make a circle?
That's a little bit better. I actually have a drawing tool that I keep meaning to bring and I haven't brought it yet. Like for the board. Anyways. So, what it wants to know is the radius of the circle. So, what is radius of a circle?
Diameter.
No, what's the diameter of a circle?
360.
Oh, 180. No, 360.
Okay, so we need to obviously do some refresher. Right, Dagan? You good with this?
You should have
Okay. This is a circle.
more like an
It's Monday, dude. You come here to
Okay. If I wanted to find the distance around the outside of this circle, what do we call that? Okay? It is like a perimeter. Very good. Perimeter is the distance around anything that's got sides. But a circle doesn't have sides, so we don't use the word perimeter. We use a different word. But it is basically the perimeter. Y'all just shut me off? You already done with me? I haven't even got to teach the problem yet. I'm just asking what's the radius of a circle? Like, what's that asking? So now I'm just going through all the different parts of the circle. Because I don't know if I know what parts of the circle are.
Outside, not the perimeter, it's the radius. No?
No. The distance around the outside is called the circumference.
Oh, with a word like that, I wonder I get one.
Pardon me, just proceed.
But all that means is the perimeter. It's called circumference.
Radius is true. From center of the circle to the circumference of the circle.
So the radius is what?
Read it aloud, Dustin.
A straight line from the center of a circle to the circumference of a circle.
So from the center to the outside edge in a straight line. This is called a radius.
It's like a radar.
Draw one more.
If you have multiple radius, that is radii. Radii. It's not radiuses.
Or radio.
Okay? If I draw from here, from one edge of the circumference to the other edge through the center, what do we call that?
It kind of looks like the thing we learned with the two lines.
Diameter.
So diameter is just 2 radius, right? Where I've drawn one radius and another radius. So the diameter is twice the radius. Okay, so what it's asking for, it wants us to find the radius of the circle. So the radius is going to be the distance from the center of the circle to the edge. So what are they really wanting us to see here? The radius of the circle is the same thing as PR. It's the same thing as PQ. Those are just radius of this circle. They're from the center to the edge. So basically, they want us to find out what x is, and then find out what the value is of QP or RP. Because they are both radius. So what did we learn? We learned just a second ago, because this line KP and this line LP are angle bisectors. They are cutting this angle into 2 equal pieces. Angle bisectors of a triangle meet at a point that is equidistant from all the sides. So that means the distance from P to Q is the same as the distance from P to R. They have the exact same value. So these two, 3 times x plus 1 and 5x minus 3, are equal. They're the exact same number because all those distances are equal from that point P. So we could say 3 times x plus 1 equals 5x minus 3. And then we would have to solve this. So I would distribute. That's going to be 3x plus 3 equals 5x minus 3. Sorry, I didn't realize I was doing that with my circle in the way. Okay? Now when I solve this, let's get my x's on the same side. So I would subtract 3x. That tells me 3 equals 2x minus 3. I would then add 3 to both sides. That tells me 6 is equal to 2x. And then divide by 2 on both sides. which tells me that x is equal to 3. So, I now know what x is, so I can take this information and plug it in to find out what either RP or QP are, because they are just the radius of the circle, which is what I'm looking for. So this would be, I'm going to plug it into RP. That would be 5 times x, which we know is 3, minus 3. That's 15 minus 3, which is 12. So the distance here from R to P is 12 units. So the first one says if the measure of angle BAF is 15. So that means this little angle here is 15. And it tells me the measure of angle CBF is 52. That would be this angle here. Then it wants to know what's the measure of angle ACF. So they're asking what is the measure of this small angle here. Okay, so the good news is because all of these lines are angle bisectors, that means they're cutting the angle into 2 smaller equal pieces. And if you look here, I've got a big triangle that I know that this angle plus this angle plus this angle has to be 180, because the 3 angles of a triangle have to be 180 degrees. So because this angle was 52, we know that this angle is also 52, because they're angle bisectors. If this angle is 15, then we know that this angle is also 15, because again, it's an angle bisector. And so I don't know what this small angle is, but I know whatever it is, that this one is the same, right? Because angle bisectors. I know that these two added together, plus these and these, have to give me 180, because they make up that bigger triangle. So what I would do is I would say, well, what is 15 plus 15 plus 52 plus 52? Well, that's going to be 30 and 104. So in these two angles, I have 134 degrees, which means I have to subtract 180 from that to give me 46. So I know that in this entire big angle C, it has to add together to be 46. But if it's cut into 2 smaller equal pieces, what do those 2 smaller pieces have to be? If the entire thing is 46, the smaller angles are
23. Is it not 139?
23. It's what, 139? Adding these together?
Yeah.
That's a 2. You put 57. You probably did 57 instead of 52. Because that would be 30
Yeah, I did.
and 104. Okay, so that would be A part. Any questions here on A part? Okay, now B part, we're looking at the same diagram, but we're going to be given different information, which means we could have different numbers in play here. So this tells me if from E to Y, E to F. E to F is 3y minus 5. So this one here is 3y minus 5. And it tells me from D to F, which would be here, is 2y plus 4. Then what's the distance from A to B? So what they're wanting to know in the end is, what is this distance here in green? Okay, well, I'm not really sure how I'm going to find that green line yet, but I know that EF and FD are equal because they are both perpendicular bisectors of that line. So I could say that 3y minus 5 has to equal 2y plus 4. So that means the distance here, when I solve that, subtract 2y, that tells me y minus 5 equals 4. So y is equal to 9. Ooh, I didn't read the question correctly. That's why. Well, I'm not looking for that green. I was going to say that's going to be challenging to find the green. The question was, what's the distance from F to AB? So I'm looking for this distance here. Okay, well I know that the yellow and the black lines are all equal. So if I can find the measure of one of the black lines, which I now know y is 9, I can plug that in. So that's going to give me 2 times 9 plus 4. So that gives me a distance of 22. So right here, if this distance is 22, then that means from F to AB is also 22. So the distance here would be 22.